In this video, we're going to talk about combining probabilities and ways we can do that. So we're going to expand on kind of what we talked about previously about and probability. But first, let's kind of use an example to help us do this. So let's set this 10 prizes in a bag, and people are going to draw them at random. And here's what's in the bag: the 2 yellow erasers, 3 green calculators. I think that's supposed to say 4 red abilities of these. So for YE, that's referring to yellow erasers. And that means that there would be 2 out of 10, which we could reduce by 2 to get 1/5. Okay, so then yellow calculators, there's only 1 out of 10. Green calculator, that has 3 out of 10. And then a red eraser, there's 4 out of 10, which reduces. Okay, so now let's do it by how many calculators are there? So what's the probability that we're just going to have a calculator? So since there's a yellow one and green ones, that would be a total of 4 calculators, which is 2/5. So 4 out of 10, oops, which is 2/5. Okay, then for erasers, we have 2 yellow ones and 4 red ones, so 6 out of 10, which reduces to 3/5. And then just red objects in general. So we have just the red erase, and then yellow objects. Since there's 2 erasers and 1 yellow calculator, that would be 3 out of 10. And then for green objects, the 3 green calculators use these. But before we do that, I want to talk about some ideas that we've discussed a little bit. I want to go into more detail. So the idea of OR events. So for this particular example, we're going to be thinking of this as drawing one thing, okay? And there are 2 scenarios that we're going to see. One is we'll be looking at 2 things that are what we're going to call disjoint. Categories that are disjoint. So what that means is that they have nothing in common or no overlap. So up here, 2 categories that have no overlap would be like a green object and a yellow object, because we're not going to have an object that's both. It's either yellow or green. Okay, the other possibilities that there is overlap. Ooh, sorry. Overlapping, meaning that they do have something in common. Hopefully, let me write that above. Something in common. I've noticed that sometimes with tables, it gets a little bit weird. So I apologize that that's written weird. Okay. And then we have the idea, this formula is what we can use, okay? We would just add the 2 things together. When it has overlap, that's when we use the other formula we've talked about, which is you add the 2 items together, the 2 probabilities, but then you have to subtract what they have in common. So that's the formula we would use for when there is an overlap. Okay, so then in and events, that's when we're talking about drawing multiple items. And there's 2 scenarios here. The first is independent events. Oops, it's going to get weird on me again. Independent. I don't know why that's floating up there. That's so weird. Okay, let's try it. All right. And as it kind of implies, it's 2 things that don't affect each other. This happens when we actually do something called with replacement. And again, I'll draw above with replacement. meaning when you draw an item and then put it back into the bag and draw another item, by putting it back in the bag, you've kept the probabilities always the same. One of the things, yes, I draw a yellow calculator out of the bag and then put it back in. I could still draw a yellow calculator out of the bag the second time. All right. The probability of me getting a yellow calculator is going to remain 1 out of 10. But if you don't have replacement, that's what we have. Dependent events. I'm just going to actually do it here at the bottom. Dependent. And that's without replacement. So if I draw an item out of the bag, let me use a different one. Let's say we have, let's say we draw a yellow eraser out of the bag. So we have one of the yellow erasers in our hands. That means that the odds of the second time, if we're not going to replace that, the odds of getting another yellow eraser has now changed. It's only got a 1 out of 9 chance that I'm going to get that yellow eraser. So odds change when we leave things out of the bag. That's why they are called dependent, okay? So for the case where they're independent, we just multiply the two probabilities together. When they're dependent, we will multiply the probabilities, but one of them is going to be conditional. And a conditional probability is when the probabilities have kind of changed based on a condition. We'll get a chance to kind of look at that with an example now, with the example we were just kind of doing. So let's try this. What's the probability of drawing a yellow item or a green item? Okay, so I actually suggested that earlier. So when we look at yellow and green, and it's an or, I notice that they have nothing in common. They're disjoint, okay? Things that are yellow and things that are green have nothing in common. So I can just add the two of them together. That's this equation right here, this very first category. So I'm going to add the probability of yellow plus the probability of green. Here, I'll just write it like this. That's not probability of green. Okay, which was 3/10 plus 3/10, and that comes out to 6/10. Okay, so what's the probability of drawing a red item or a eraser? So the question is, coming back up here, a red item, so that we have 4 out of 10 red items, and then for erasers, there's 6 out of 10. However, in this particular version, we do have overlap. So even though we're doing or, this is an example where we have to worry about the overlap, that they have something in common, because we have 4 red erasers, 4 things that are both red and an eraser. So we're going to calculate the probability, or I'm sorry, we're going to find the probability of red plus the probability of being an eraser, and then subtract the probability of being a red eraser. So probability of red is 4 out of 10. Eraser was 6 out of 10. And then 4 red erasers. So that's what we're going to calculate. And when I do the math, that's going to be 6 out of 10 or 3/5. All right, let's look at and. So this is if we put the item back each time. So what's the probability that we draw 3 red erasers in a row? So the first time I go to draw a red eraser, there's 4 of them, right? Out of 10. And if I'm going to put that back into the bag, that means then that the next time I go to draw a red eraser, it's going to be 5 out of 10 again. And then the next time it's going to be 4 out of 10 again. And I'm multiplying them because that's this formula right here. This one, multiply. So because these are independent, we're replacing, we're just multiplying the probabilities together. And the probability is always going to stay the same. So this becomes 64 over 1,000, which as a fraction, I'm just kind of sticking to fractions right now. So if we do not put the items back each time, that means that the very first eraser we pull out is still going to have a 4 out of 10 probability. But now we only have 3 red erasers in the bag, and we only have 9 items in the bag. So the probability I'm going to pull out another red eraser is 3 out of 9. That's the conditional. We've changed our total. So now I have 2 red erasers in my hand. So now I only have 2 red erasers left in the bag out of 8. And when we multiply that, let's see, that's 12, 24, and then that's 720. And that reduces to 1 out of 30. And that's how we kind of combine these into multiple probabilities combined